Let's go ahead and get started. Thank you everyone for joining us for today's Montana Institute on Ecosystems Rough Cut Seminar Series. Before I introduce our speaker for today, I'm just going to go through a couple of housekeeping items and then I'll introduce Wyatt and we'll go from there. So the first housekeeping item is just to make sure, you'll notice that you were muted upon entering the seminar, and just make sure that you keep your mics muted throughout so we're not getting any noise interference. The second housekeeping item is just related to Q&A. So we're going to hold all questions until the end of the seminar. But if anything does come up while Wyatt is presenting, please feel free to enter that into the chat and then I can moderate and make sure that he receives that question. But at the end, you can also unmute and ask the question yourself at that point. And the final housekeeping item that I have is we are recording today's seminar, and so I will post the link to where that will be posted on the IOE website in the chat towards the end of today's seminar in case you know anyone that wasn't able to make it today, or if you want to go back and view it at a later time. So just making everyone aware of that. So today we have joining us Dr. Wyatt Cross. I'm very excited about hearing about this project. But Dr. Cross is the director of the Montana University System Water Center, USDS-funded Water Resource Research Institute. The Water Center facilitates and conducts activities that advance understanding and stewardship of water resources across Montana, and also serves as the primary nexus between the Montana University system and diverse water resources stakeholders, including state and federal agencies, NGOs, citizens, and the private sector. And Dr. Cross is also an associate professor in the MSU Department of Ecology with a research program focused on river ecosystems. So with that introduction, again, very excited to have you here, Wyatt, presenting to us. I will go ahead and turn it over to you.
Awesome, thanks so much. Can you hear me? You can hear me, okay,
yes,
great. Everybody, thanks for being here. I really appreciate your time on this crazy day. What I want to talk about today is evaluating irrigation efficiency. This is a project that we've been working on at the Montana Water Center for about a year and a half now. And it's talking about irrigation in the context of building a sustainable water future for Montana. I want to acknowledge my co-authors first, and most importantly, Whitney Lonsdale, who has done the lion's share of the work on this stuff. Chuck Dalby at Kintla Enterprises in Helena, and Ann Schwen and Sarah Malloy at the DNRC, also in Helena. So what I want to do today is advance the slide.
Sometimes you have to like refresh. There you go, click it.
So what I want to do today is I'm going to talk very briefly about water generally and water scarcity, and that'll help motivate kind of where irrigation and irrigation efficiency fits into that picture of water scarcity. But I want to spend most of the time talking about this product that we've been working on in terms of understanding how changes in irrigation practice influence irrigation efficiency. What are the consequences of that for water supply and other water users? And what are some potential adaptation strategies we might go forth with moving ahead in the future? So water is everything, right? We depend on water to produce our food, to power and supply our homes, to fuel and cool our industries, to recreate in, and also to sustain biodiversity and ecosystem goods and services that we care about. But water as a resource is finite. But unfortunately, our demand for water is not. So this is a recent paper in 2018 that basically estimated that over half of the human population face severe water scarcity at least during 1 month during the year. And this is particularly true in arid regions of the world, such as the Western US. And so as the population continues to grow and continues to redistribute, the scarcity is just going to continue to kind of ramp up. Now, water scarcity, defined here as this region where our demand for water approaches or exceeds supply, creates a massive amount of tension among these different demands for water, and forces us to make really difficult decisions about how our water is partitioned in society and nature, as well as how we deal with this from a management or policy perspective. Now, in the western U.S., water scarcity isn't theoretical. It's here. This is a graph that shows changes in water availability and water use over time in the Colorado River Basin. And you can see in the mid 90s here that demand for water started to exceed supply in a way that's basically not sustainable. It's actually really rare for the Colorado River to even make it to the Gulf of California anymore. So it's a big deal, and it's happening locally. This is becoming way more common across the West. This is an interesting figure that shows depletion of river flows in the month of September. And so basically what this is doing is comparing present day measurements of flow with modeled estimates of what flows would be like without water withdrawals. And you can see very significant depletion in our rivers across the Western US as our demand starts to outstrip supply. This is telling us something. And I should mention that these levels of depletion, 50% and higher, are well beyond the threshold at which we know that biodiversity and natural ecosystem services become severely degraded. Now, in our own backyard, this is something that surely affects us as well. This is an example from the Bozeman Integrated Water Resources Plan that basically predicts that demand for water in the Gallatin Valley, and particularly in the city of Bozeman, is likely to exceed supply in the next 10 to 20 years. And with our current rates of population growth, by 2042, we're going to have a water deficit, a water gap. So we're going to be down about 6,600 acre feet per year. And so, as with many other locations across the West, there's this kind of huge looming questions about where is this water going to come from, as well as how will any conserved or saved water in the future might be distributed, or how might that water be distributed among the various competing demands, right? So how do we deal with water scarcity? This is a really big deal. How do we tend to deal with it? In the 20th century, we tended to deal with this by increasing our supply, right? So focusing on the supply side of this equation. So the Bureau of Reclamation, the Army Corps of Engineers, and others constructed dams and large water projects that enabled us to continue to grow populations and grow food. But in the 21st century, this discussion has shifted big time to finding ways to reduce our demand for water. And that's largely because of the huge economic and environmental costs of new storage projects, as well as the inherent vulnerability embedded in these sort of engineered approaches. And so how do we reduce water demand? What we need to do is we need to look at where most of the water use is occurring and figure out where we might have the best opportunities for water conservation. So this is a graph from the USGS over, I guess, 1950 to 2015, showing the major water withdrawals by water sector. And you can see it's pretty obvious that there are two of these bars really stand out. The yellow bar is water withdrawals used for thermoelectric power. This is the largest amount of water used in the U.S., but it's not that consumptive. So most of the water that cools thermoelectric plants actually goes back to the source and can be reused for other things. Irrigation is the second bar here in green, and of course it's a huge user of water. And a lot of the water used in irrigation is consumptively used. And so it passes through a plant, gets evaporated or evapotranspired, and it's lost from the local system. Okay, so irrigation is a big deal in terms of water use. In Montana, irrigation represents the largest consumptive use of water. This is from the Montana State Water Plan. And you can see that agricultural irrigation consumption dwarfs things like thermoelectric power plant cooling, domestic uses, industrial uses, and so on. And so this is important because how irrigation water is managed in Montana will play a huge role in deciding our water future and the sustainability of water availability in Montana. For those of us in Bozeman, this is a little closer to home, the Upper Missouri River Basin. This is just a pie graph showing differences in consumptive water use among the different sectors. And again, irrigation consumption is 82.2% of the total. And although water savings or conservation in these other sectors like domestic uses and municipal uses and so on are important, irrigation is obviously our greatest opportunity for conservation. And so the question that's been asked for decades is how do we become more efficient in agricultural water use? Or essentially, how do we squeeze more crops out of each drop? In the irrigation world, this is typically referred to as efforts to increase irrigation efficiency. And we're defining it here as just the ratio of the total water consumed by crops to the total water that's diverted from the source, from the river, from the canal, whatever. And so the agricultural community has been very focused on increasing this ratio over time in efforts to conserve water. How have they done this? So since the mid-50s, the most popular approach has been the modernization of irrigation infrastructure. So switching from, say, relatively inefficient flood irrigation to sprinkler irrigation and things like lining of ditches and canals, basically all to get a higher proportion of the water that's diverted to directly fuel plant growth. And perhaps even saving water by reducing the amount of water that needs to be diverted from the source. And there's been a huge amount of money and effort put into increasing irrigation efficiency. This is from February, the Bureau of Reclamation has spent millions and millions of dollars on helping water projects and farmers increase their irrigation efficiency. And all of these projects have the purported goal of essentially using less water to grow food. Now, in the past several years, there's been much written about what's being called this paradox of irrigation efficiency, and the fact that efforts to increase irrigation efficiency may not always reduce water consumption. And there's a huge amount of uncertainty around this topic. There's very little consensus among water users. Anyone you talk to kind of has a different story about this, policymakers, agencies, and so on. And so there's a lot of confusion about, are these increases in efficiency actually saving water? And this makes decisions about irrigation management and water conservation super, super difficult. So that's kind of the backdrop, and those are the things that motivated us at the Water Center to try to help get a handle on this question in Montana. And so starting in March of 2019, we convened a technical working group where we brought together a big group of water stakeholders in the state to basically discuss and investigate this super, super important topic. In particular, we wanted to try to consider all the various perspectives that influence irrigation practice with the goal of providing an unbiased synthesis that can be used by policymakers, funding agencies, management agencies, and even producers on the ground to make decisions that match their particular goals or objectives. I'm happy to say that we're printing copies of this right now, actually. And so we should have copies of this available really soon, and a web presence in the next month or so. So look out for copies of this product. Okay, so now to carry out this technical working group, we did a variety of things. We had online webinars about various topics. We had focused technical meetings, for example, one on hydrology. We had broad participatory meetings, getting input from all these different stakeholders. We gave public talks and outreach, and then we interviewed stakeholders. In particular, we interviewed irrigators on the ground to sort of ground truth, whether what we were talking about resonates with them. And so we brought a whole bunch of people from different backgrounds, different perspectives together to have a productive discussion about these things. And so what I want to do now is spend the rest of the time giving an overview of some of the things that we've learned in this process. And so we're going to start by talking generally about irrigation in Montana and why this topic of whether changes in irrigation practice are really saving or conserving water is not very straightforward, right? So a little bit of background about irrigation. Irrigation's been huge in Montana. It's been a big part of our identity, our culture, our livelihoods, and our economy since the mid-19th century. And although irrigation is the largest water consumer in the state, the production of crops and grasses and so on contribute to this nearly $5 billion agricultural industry. So irrigation is hugely important in the state. But it's also had a massive impact on hydrology and on the landscape. And so this has happened through this huge network of conveyance infrastructure in irrigated valleys, ditches and canals that help spread water from rivers out onto the landscape and deliver that water to farms. This is an image here zoomed in of the Gallatin Valley, and you can see, I mean, it's just an absolute spider web of water infrastructure to feed farms. Now, what's interesting is that, much of the irrigation water that's spread out across the landscape doesn't ever make it to a plant, okay? But it seeps into the groundwater in these alluvial floodplains. This is an example from the Bitterroot Valley here, and you can see that the little circles all around here are showing a variety of wetlands in the valley that have been created by leaky and inefficient flood irrigation. And of course, these wetlands now support things like birds and other wildlife in the valley. Now, over time, we've also seen a lot of development in these floodplains. Each of these little points on this graph is a well for a home or a small development. And so now this incidental recharge from irrigation that seeps into the aquifer supports an increasing amount of domestic use as well. In addition, these vast sort of floodplain sponges, water sponges, they slow water down and allow it to slowly leak back into surface waters as something that we call return flows. And you can see that here for Flint Creek, this hatched area, are return flows that are coming back late in the summer. And so that slow leaking of water can fuel river flow later in the summer, fall, and winter. And that's important because those return flows can serve other purposes, right? So those return flows can be really important for downstream irrigators, for supporting recreational fisheries, as well as supporting native fishes and ecosystems that we care about. And so it's complex. We're in a weird place where it's sort of a brave new irrigated world that we've created over the past 150 years. But our irrigated valleys really represent novel hydroscapes, right? There's lots of leaky irrigation that's influencing the hydrology in ways that we've become very accustomed to. But changes are taking place. Okay, so what we're seeing over the past, say, 50 years or so, but more so in the last 30 or 40 years, is a change in the way that we're applying water to farms, okay, in the context of trying to increase irrigation efficiency. This is a graph that shows summarized data for about 17 Western states, of which Montana is one. And you can see that the blue line here shows total water use has not changed much at all over this particular time period. But you can see gravity irrigation water use going down. That's the classical flood irrigation. And then pressure irrigation water use going up. This is handline sprinklers or center pivot sprinklers. Okay, so the way that water is being applied has changed a lot across the western U.S. In Montana, so these are data that Chuck Dalby, one of the authors, helped us collate on acres converted to sprinkler irrigation. So this just shows the total number of acres converted to sprinklers or center pivot by the major watersheds in Montana. And the big picture here is that about 20% of flood irrigated land in Montana has been converted to sprinkler irrigation. And although we don't have the numbers here, there's also been a significant amount of lining of canals. Now, I want to point out that there are obvious reasons for wanting to make these changes, right? That all make good sense. So modernizing irrigation is reducing the cost, but more importantly, the amount of labor necessary. It's helping farmers increase their crop production. It can help improve water quality in some cases. There have also been financial incentive programs from the state and federal agencies that have helped farmers afford to do this switch. And finally, there's this perception that changes will lead to more crop per drop and savings that might be able to be applied elsewhere. But of course, these changes are having a large influence on the hydrology of these irrigated valleys that we've become relatively accustomed to. And probably one of the most consequential of these has to do with this connection between surface water and groundwater. So when producers are switching from flood to sprinkler irrigation to increase their efficiency, one of the most obvious responses is that less water is applied to the ground, less of that water seeps beneath the soil profile, and this means that the quantity that each farm has to divert is reduced. Okay, so the amount of water being diverted from the source typically declines. The same thing tends to happen when canals and ditches are lined. So less water seeps down underneath the ditch, and therefore less water needs to be diverted for that canal to carry the same amount of water. Now, it's often assumed, therefore, and this is the key assumption in modernization projects, that these changes reduce water loss and create water savings. But it's really important to question whether these changes result in true water conservation from, say, a mass balance or a hydrologic perspective. Does increasing irrigation efficiency actually save water? And the other question is here that we have to ask ourselves here is, what was happening to that saved water before the changes in irrigation took place? Now, just a cartoon here, but in many cases, this extra water was seeping into the vast alluvial river valleys, the vast aquifers, and eventually returning to stream flow, where it may have been reused by downstream irrigators, or perhaps it was benefiting fish, other aquatic species, or processes. In this case, of course, the water wasn't really lost in the first place because it was being used or reused at other locations and at other times. And when changes in irrigation and conveyance method take place, it may not actually be saving water. It might just be moving water temporally and spatially within the system. So maybe it's keeping it in stream at the time of diversion instead of spreading it out and having it return to surface water sort of days, weeks, or months later. And so the specific benefits or impacts of these changes on other water users is really going to depend on when and where water is needed in these other locations across the watershed. Okay? But all this begs the question, what actually constitutes real water savings? And from a mass balance perspective, from a hydrology perspective, water is only saved by reducing the amount that's removed from the system in question. So removed from a farm, removed from a canal, removed from a watershed by reducing evaporation from these things or reducing plant evapotranspiration. And many of the changes associated with modernization of irrigation may not actually achieve these kinds of water savings. In fact, an increasing number of studies suggest that modernization of irrigation infrastructure can actually lead to increased water consumption. How can this happen? Well, this can basically happen at the farm scale because more uniform and consistent sprinkler irrigation can lead to more robust and dense plant growth on farms. Sprinklers may also allow irrigation on lands that were previously unproductive under flood irrigation. And at the watershed scale, if we think at a broader scale, water not diverted in one location can be used by other irrigators downstream. So junior water right holders might be able to gain access to water they didn't have previously. And so these changes to sprinkler irrigation aren't necessarily leading to true water conservation. Now, there are many examples of this across the West, but one that's relatively close to home is in the Teton River Basin here, where most of the headwaters are in Wyoming, in the upper basin, and then the rest of the watershed is downstream in Montana. Prior to 2000, in this watershed, there was a lot of conversion going on, but most of it was happening in the upper part of the watershed in Wyoming. And what was happening is this was leading to increased crop consumption in Wyoming and reduced return flows downstream. And that seemed to be working okay for a while, but came to a head during the drought between 2000 and 2006 when there were extreme water shortages. There's a big drought. And so during these drought years, this basically led Montana to file claims against Wyoming Supreme Court, basically stating that Wyoming's conversion to sprinklers was increasing consumption and reducing these return flows that farmers were using downstream in Montana. In this particular case, the Supreme Court ruled that the improvements in irrigation efficiency in Wyoming were actually permissible under the Yellowstone River Compact. And it remains the case today that changes to irrigation method, so changing to sprinkler irrigation on the same acreage, doesn't require state approval, even if it might lead to increased consumption. And this was something that was identified in our working group as a super critical area of policy that still deserves some discussion. Okay, so in many cases, irrigation efficiency leads to increased consumption, and it can actually have effects on other water users in the system. But in contrast, in some places, it's the case that the benefits of conversion, so diverting less water and leaving more water in the stream at the time of diversion, can outweigh the risks and potential impact of increased consumption. And this is especially true in streams and rivers that have sections that are routinely dry in the late summer, or where streams are say, disconnected from their main stem rivers, right? And so I want to give you an example of where this has happened. So this is an example from Gold Creek, a tributary to the Clark Fork River. And here's what the deal was. So prior to 2007, all the farmers in this watershed were flood irrigated. And the issue was that large diversions for floods throughout the summer and early fall to feed second and third cuttings of grass were leaving a lower proportion of Gold Creek, that lower section in red there, completely dewatered in most years. And this was basically severing the connectivity between Gold Creek and the Clark Fork and influencing the movement of trout from the Clark Fork up into Gold Creek. And so this was having a pretty serious negative impact on the trout fishery. And after 2007, two of the larger ranches at the lower end of Gold Creek basically converted to sprinkler irrigation. And what happened was this change reduced their necessary diversions during the summer and fall and essentially rewatered this lower section of Gold Creek. This allowed trout to now spawn in this tributary and so improve the fishery to some degree. And so this was a positive outcome from switching to sprinkler irrigation. Now, at the same time, it's important to point this out that folks up high in the watershed maintained flood irrigation. Okay? And this meant that there was a continued contribution of return flows from their flood irrigation downstream. So this is an example where the particular configuration of flood and sprinkler irrigation, flood up high, sprinkler down low, actually helps to maintain stream flow and connectivity for the fishery at the lower end of the watershed throughout the year. And so I hope it's clear that from these two examples, the impacts of changing conveyance methods on water supply are super site specific. And each valley or local system is going to need to understand and assess the potential consequences of changes in their irrigation practice. And if we think about generalized changes to stream flow hydrographs in response to different types of irrigation, we need to recognize that the shapes of these curves, where they rise and decline throughout the year, where things like return flows do this bump and kind of come back to feeding stream flow, this is really going to depend on characteristics of that particular location or watershed. And the bottom line is we need more local data and monitoring to truly understand these changes and respond in an informed way. These changes of course, for the ecosystem are really consequential because many of the species that live in these river ecosystems depend on the natural flow regime, they depend on the natural temperature regime, and on natural geomorphic processes that occur. So if one of our goals is to sustain natural river ecosystems, we need to be well aware of these things and try to manage irrigation as best we can to support these ecosystem services. Okay, that seems like I'm going faster than I expected, but maybe that's good. I want to spend just the last part of the talk here focusing on some of the adaptation strategies that came up during our working group. And I won't have time to discuss all the things that came up, but I'm hoping you'll dig into this publication and read more about it. It comes out if you're interested. And so, given the complexities of irrigated agriculture and that it's not very straightforward, how do we work towards a sustainable water future for Montana? And how do we do this while maintaining our working lands, while maintaining natural river ecosystems and so on? How do we balance all these various things? The first and probably the most fundamental recommendation that came out of our working group was that we need transparent monitoring and reporting of water use, as well as state-of-the-art models to help us estimate water consumption and its influence on water supply. Not only would this help us protect water users and their rights in the future, but it would provide the basic and essential data we need to play out different future scenarios and make informed decisions. This is all very possible, but it's going to require some investment from the state and from others. We also need to update water budgets in the state. So we simply just can't manage what we don't quantify. In the 70s, the Soil Conservation Service put out this water conservation and salvage report where pretty rough water budgets were constructed for Montana. But it's certainly time to leverage new technology and expertise to provide a much more quantitative foundation for making decisions in the future. So data. This is critical for any of the decisions we make in the future. Second, another adaptation topic that was really key in our discussions was the idea of finding ways to support adaptive management of our alluvial river aquifers, right? And the idea here is basically to use our existing canal infrastructure, our farm fields, our floodplains, and even constructing engineered structures to temporarily store water in the aquifer in the spring so that return flows can be used later in the season for farms, for rivers, and for other uses. And I've got an interesting example of where this is, a case study basically of where this is working. And this is actually coming from Idaho on the Teton River. It's a project called the Teton River Recharge Project. And essentially what was happening in the Teton River Valley was that in the 70s, most of the producers converted from flood to sprinkler irrigation. And this was a big deal. It helped these farmers increase their crop production and things were going swell. But what they also noticed is that in the area, there was loss of wetlands and springs, well levels were declining, and there were reduced late summer stream flows. And this was causing a lot of stress for the recreational fishing guides and for the ecosystem. And so there was sort of this shared, basically shared concern over what was happening to water in the Teton River Valley. This all led to the formation of a group called the Teton Water Users Association. And this project, which was basically trying to find ways to maintain agricultural production while supporting in-stream flows for the river ecosystem. And basically the overall goal of this project is to slow down spring runoff, store water in the alluvial aquifer, and try to increase summer stream flows later in the season. And so in a return to flood irrigation-like management early in the spring, folks on the ground here are now diverting water as soon as it's legally available and spreading it out through this reactivated canal system. There's also some recharge taking place through these very focused infiltration galleries across the landscape, but it's having a really significant effect on the system here. So this is a I think, a really a win-win example. So the canal system that was once defunct, once they switched to sprinkler, is now back up and running and is providing aquifer recharge in the spring. Late season stream flows appear to be increasing, and the fishery appears to be hanging on there and doing okay. Importantly, canal companies and irrigators are being paid for the aquifer recharge that's being provided by this practice. And so this is, I think, a really interesting example of how agriculture and river ecosystems can both benefit if there's some thought put into the specific hydrology of the region. And if you're interested in more about this, these websites down here can guide you to some more information. Now, in terms of supporting management of these aquifers, another recommendation from our working group was basically to identify and consider places where what we're calling hybrid irrigation management might help us accomplish local objectives. And so again, in this case on Gold Creek, this particular configuration of flood and sprinkler irrigation allows ample water for producers to grow crops, but also flows to support the local fishery. Okay, so this is a case where if you know something about the hydrology and the configuration of the different types of irrigation in the landscape, we can help manage the system to support multiple demands. And the last thing I'll focus on here is this adaptation strategy, which is basically we need to enhance and provide opportunities for true water conservation. And so for the agricultural sector, what this means is reducing unintended water consumption, whether it's by reducing evaporation from fields or canals, or reducing unintended evapotranspiration from crops. This is going to be really important. In addition, we need to make sure that changes to irrigation practice don't inadvertently increase water consumption, and that's going to be a little more tricky to do. Secondly, the adoption of drought-tolerant or water use efficient crops is going to be really important moving forward, and this is possible. So some plants like lentils in Montana, for example, are much more water use efficient and drought-tolerant. And so these cases, it's really possible to get more crop per drop, essentially. But this can be really difficult to do without incentives that help producers navigate this change, because it's much easier to do what you've been doing for years, right? Finally, and there are many examples of this across the West, water leasing programs or water banks can be developed, which have been very successful in the context of directing water that's conserved in agriculture to things like in-stream flows or sustainable development projects. And when these transfers or these leases are done well, they can help during times of water scarcity to try to strike this balance between all the various multiple demands for water, and doing so in a much more sustainable way. And so all of these things will be increasingly important as we move forward. And there's a lot I didn't focus on here just because of time, but I encourage you to look at the publication we're about to put out if you want more information about other ideas for adaptation. But I want to finish up here with just a few take-home points. The first one is that changes to irrigation practice have complex effects on hydrology, and these are not easily generalized. And so we can't go on thinking that upgrades to infrastructure always save water. And we need to shift our thinking towards a more nuanced understanding of these things based on local site-specific information. Second, striking a balance among the different demands for water is certainly possible, but it's going to require conversation and collaboration among water users, agencies, policymakers, and so on to get this done. It's also important to point out that it's probably going to require economic incentives for water rights holders who own the legal right to this water. Third and finally, I think it's probably important for us to recognize that most of us want the same thing. right? We want to maintain our agricultural landscapes and livelihoods. We want to sustain healthy streams and rivers. We want to promote growth in our valleys that's smart and sustainable. And water is really right smack dab at the center of this. And so if we can work towards building a collective vision for our water future, and basically trying to understand these things, that irrigated agriculture can play a super important role in mitigating water scarcity. Now, I'm not going to let you get away without one last point, and that is this: that the final thing I guess I want to say is that we can't ignore the fact that climate change is exacerbating water scarcity in the West. So when we're thinking about scarcity that might be driven by changes in agricultural practice, or when we're thinking about scarcity that might be driven by population growth, we've got to remember that climate is playing a huge role in increasing our demand for water. So CO2 and warming, increasing plant water use and plant growth, as well as decreasing our supply of water by reducing snowpack, by warming and increasing drought severity, and so on. And so the much bigger picture here is that efforts to reduce greenhouse gas emissions are absolutely critical in terms of helping us to secure our water future as well. Okay, so the last thing I just want to say is I want to thank all the working group contributors that spent their time helping us understand this topic and were really generous with us. So that we really, really appreciate all these people. I hope you can see them. I know their names are small. And our contact information is here, and look out for our publication very soon in the next few days. So thank you, and I'd be happy to take questions.
Wonderful. Thank you so much, Wyatt. Yeah, if I haven't seen any questions come through the chat during your talk, but if folks, you can either enter your questions in the chat and I can help moderate those, or please feel free to unmute yourself and you can ask Wyatt directly too. I see Brian says he has a question. Brian, would you like to unmute or?
I think, am I unmuted? Can you hear me, Madison?
Yes.
Awesome. I think I have a video, but I'm not really sure because I can't see it. This WebEx thing is a mystery, given that University of Montana doesn't use it. It's just a Bozeman thing. Anyway, good to see you, Wyatt. Great presentation. Thanks so much. It was really polished and well thought out, and the flow and consistency of your message was great. I kind of want to put you on the spot with a tough question, if I might. I'm a huge fan of adaptive management. I think adaptive management in a small, contained, controllable situation is a real benefit. And I'm curious, given the context of Western water, given the context of prior appropriation administration in Montana specifically, how do we incentivize farm scale to regional scale adaptive management programs? And so I'm thinking it not only incentivize producers to engage in it, but also incentivize our agencies and our bigger funders to monitor it. Because we all know that one of the big downfalls and pitfalls of adaptive management is just the long-term commitment of buying into that monitoring program and looking at that data. So I'm super curious if you've got some wonderfully bright ideas around incentivizing adaptive management programs.
Oh yeah, I mean, I think incentivizing the agricultural community to be involved in that is huge. And now I'm not answering your question. No, I think that there's got to be there has to be they have to be involved right from the get go, right? You can't come to the agricultural community and say, hey, we figured out what the deal is with the water. We're gonna work it out. Just don't worry about it. Do this, do that. So I think bringing them in like right in the beginning in terms of adaptive management, but also like they've got to be incentivized. It's got to make sense to them, right? If you're trying to incentivize farmers in Gold Creek, Montana, to support farmers in Washington, that's going to be a tough sell. So I think that making it relevant locally is really important. Yeah, I mean, adaptive management. I think that one of the biggest things that we're going to face is changes in land use, right? And so switching to these homes in these valleys, or like in the Gallatin Valley, having this large amount of development, and that I think is going to require entities that are neutral bodies like water banks, right, or water leasing entities that serve as a sort of middle ground for helping adaptively manage valleys, because it's really complicated. So you need someone thinking about all these different demands at the same time. We need water in the Gallatin for the fishery. We need some water for the development that's occurring, et cetera. So you need think tanks and people and scientists to sort of set the stage, but you want to bring everyone in at the ground floor so that they're bought in. And now I'm just starting to babble. So, but I think that's all true.
Thanks, Wyatt. I appreciate it.
We had a question come in from James in the chat, and he asks, what was the court case in eastern Montana?
Yeah, so this was I could get you in our document. I have the actual number, but it was Montana versus Wyoming. Hi, James. Supreme Court, and it's all documented, and I can get you that information if you want.
Cool. Thanks, Wyatt.
Okay.
Wyatt, this is Bruce. I have a question. And it's similar to what Brian was saying, in that I too am a fan of adaptive management, but I think that what's crucial about adaptive management is local information. And as you indicated before, that one size doesn't fit all, or one rule of thumb doesn't fit all. That we really have to examine hydrology unit by unit, kind of how these systems work, and how to make them perform the best for us and still maintain their services, I'll say. Do you think that the question then is Montana properly equipped, or can you comment on what kind of instrumentation we might need in order to really do this adequately? Or maybe we are there.
No, I mean, we're definitely not there. That's a great question. We're not there. There's some investment in the state in terms of water, but not enough. I mean, there's investment in the Montana Bureau of Mines and Geology to do specific studies on water, and there's other examples of that. But I think in any of our river valleys, we don't have a comprehensive understanding of the hydrology at these kinds of scales, right? And that's a huge deal. In some states, they've invested massive amounts of money into setting that groundwork. So okay, information is the base. We have to measure and monitor everything. We need models that'll help us do these future scenarios and so on. And then if those are trustworthy, and that's the key, like developing these, they have to be developed in a way that folks in the state trust these things. Then it's really super effective. I don't think we're there yet, but we need to be, and it's a matter of sort of convincing folks in the state that this is one of our most important challenges, and so getting the legislature to pass a bill or something that allows us the resources to build a sort of Montana Water Observatory or something, right? Where you have universities, agencies, firms, others working together to build that base of information. Because, I mean, adaptive management, you start with a hypothesis, and you gotta understand your baseline, make a change, and then loop back, and we can't do that without the information. So, but it's a good question. It's a hard challenge.
Yeah, thanks.
Awesome. I was just looking a couple of comments in the chat. One from Sarah as a follow-up to Brian's question. She said, I'd also add that educating agencies and policymakers to modify funding mechanisms, programs, and priorities to support hybrid irrigation management where it makes sense, for example, will be key. And then Brian followed up and said, consistent engagement across our spheres will be key to building these communications pipelines. And then suggested a virtual Montana water happy hours over the winter. So possible, yeah.
There you go.
Discussion.
Yeah. Totally agree.
do we have any other questions from folks on the line? Again, feel free to either enter those into the chat or you can unmute yourself and ask directly to Wyatt.
Hey, Wyatt, this is Jeff Reed here. I'm in Paradise Valley, and I know Chuck Dalby modeled for us in our valley at one point that about 15% of the consumptive irrigation use is actually used in the plant, and the rest returns, even across both sprinkler irrigation and otherwise. And I didn't see that data. So, you're talking roughly 85% is still in some way returned to the ecosystem. And I'm kind of guessing that when you said these local regional models would really tease that out and help people to understand, how to manage with that in the local area. I just, wondering, is that pretty good science that Chuck, I love Chuck, he's amazing. But I don't see that in most of these reports. And yet us irrigators, we show up on this chart as using this huge chunk of water. But even in sprinkler irrigation, there's water returning into the aquifer. So just wondering about your comments on that.
So let me make sure I understand, Jeff. Thanks for the question. So water you're not saying water that's taken up by the plant and then not used, are you? You're saying...
So let's just use a sprinkler irrigation as an example. It was still only 15% of that sprinkler irrigation was consumed by crops, right, across scale. And so you still have a fairly significant return of water that you pumped from wherever, the main stem, and run through your sprinkler irrigation that's returning to the aquifer at slower paces, right? And it depends on the soil type, but there's still a lot of return even in sprinkler irrigation. And I might, Chuck might, I don't even know if he's on the call, he could correct me if I got him wrong, but that was the data we were given in our watershed group.
Yeah, I think there's certainly, sprinkler irrigation is not like drip irrigation where you literally have drops going into the roots of the plants, and so there is some water being put back into the aquifer from sprinklers, and I don't know about those numbers. I don't know if that I can't speak to that, whether that's accurate, but I think that there are still opportunities in sprinkler irrigation to reduce that if that's desired. Right, and so people have been tweaking their spray. These things.
yeah. We just drop them down lower. I get evaporation and I get wind loss and all that sort of stuff. I just think it's an important metric in the hydrology to make sure you call out. And if we don't know, we don't know. Or if it's too variable across soil types, then I get that.
Yeah.
But you still have to understand that a sprinkler irrigation system puts water down, not all of which is used by the plant. And you'd have to manage accordingly, right? If you were going to switch back and forth.
Yeah, totally. And I think, more data related to that is important. I know that's been estimated a lot of places, but I don't know how much that's been estimated in Montana on different types of crops and things like that. So that's an important point.
And thank you. I just want to say thank you. This was very useful for just simple users like us who are irrigators around here. And we look forward to the report. Can you tell us, I'll say one last thing. Can you tell us when and how we get it?
Yeah, so it's being printed right now, and we're going to send a bunch of these out to a bunch of folks. And if you're interested, please send me an email. We'll get you one for sure. We are also going to have a web presence, and so this will be up online very soon. You'll be able to get just the PDF or read it online in a different format. So thanks, Jeff.
Well, we've got about 5 minutes left until 1. Do we have any additional questions coming from the audience.
Hey, Madison, there's a question in the chat that says, I'll just read it for you here. Was compelled by some of the, I think it's from Adam Ziegler. I was compelled by some of the conversations where irrigators outlined their biggest infrastructure issues, thinking about how they're addressing these issues to be aligned with broader water conservation goals. And then he says it was cool to see the Gold Creek and Teton examples of win-wins in the talk. Are there other examples of win-wins? And I'm only bringing that up because I think it's a really interesting question. And maybe, Wyatt, you have some other win-wins that you could just briefly talk about.
Yeah, I mean, there are certainly more examples of that. In Montana, I'm not super sure about that at this moment. There's been a lot of win-wins, I think, in terms of these water leases, and in particular, being able to pay farmers to reduce water use during times of scarcity, and benefiting in-stream flows when that's needed. So there are a lot of examples across the West that are like that. But sorry, Adam, I don't have any other really good examples at this moment that are like the Gold Creek or the Teton River.
Awesome. Thank you, Brian, and thank you, Adam. I didn't mean to breeze right past your question in the chat. Awesome. I'm making sure I haven't missed anything else there. Well, I will kind of give a final call for questions. One more if somebody wants to step up. Okay, going once, twice, 3 times, hearing nothing, we can go ahead and end our seminar for today. So a big thank you to Wyatt again for such a wonderful presentation, and thank you to everyone for joining us today. And I did post in the chat where you can find the recording for today's seminar, but essentially if you go to montanaioe.org and navigate to media and then videos, you'll be able to find it. I hope to have it posted by the end of today. And a quick note that next Wednesday is Veterans Day and our offices are closed, so we won't have a Rough Cut seminar then, but our final one for the fall semester will be on November 18th. So join us then, and otherwise, yeah, hope everyone has a wonderful Wednesday, and thank you again, Wyatt.
Thanks you guys for having me. I appreciate it.
Thank you, Wyatt. We really appreciate it.
Awesome.
Right.
Great presentation.
Mm-hmm.
Thanks. See you later.
Sweet. Virtual applause. Thank y'all.
All right.